We'll solve problem on kinematics of rigid bodies. See what is given in this problem. In the mechanism shown, the angular velocity of link AB is 5 radians per second anti-clockwise. At the instant shown, determine the angular velocity of link BC and velocity of piston C. What is given in problem? Just see in figure. Link AB is given. Which one? Hinge supported at A, and this one is a hinge support. It is a fixed center of rotation. That means rod AB performs pure rotational motion. At the end of rod AB, bar BC is a pin connected at B, and at the end of this rod BC, here one slider or you can say piston is connected. What is given in problem? Rod AB rotates in anti-clockwise direction with angular velocity of 5 radians per second. You have to find out angular velocity of rod BC and linear velocity of piston C. Now number of bodies in given problem are 2. So each body performs which type of motion is very important. As rod AB rotates about point A whose center is fixed, therefore rod AB performs pure rotational motion. But rod BC doesn't rotate about such a fixed center of rotation. Therefore rod BC performs general plane motion. That means we will get ICR for link BC, and for rod AB center of rotation is point A. Now as angular velocity of rod AB is given, can you decide from this one if end of rod AB moves in which direction? That means the direction of linear velocity of point B. Whenever any body rotates, linear velocity of any point on the rigid body is always perpendicular to radius of rotation. That means if you assume rod AB now rotates about A, direction anti-clockwise, that means linear velocity of point B is perpendicular to AB and in the same sense of angular velocity. Therefore, linear velocity of point B must be horizontal, and as omega is anti-clockwise, VB must be rightward. This is linear velocity of point B. Once we will get direction of linear velocity of point B, which is perpendicular to AB, now you have to decide slider C slides in which direction. Slider C motion is restricted, has to slide in upward or in downward direction. Therefore, to decide the direction of linear velocity of point C, it is confirmed that VC is vertical, maybe upward, maybe downward. I will draw perpendicular to VC and I will represent VC may be upward, may be downward. This is VC. Perpendicular to VC, so you will get a horizontal line as VC is vertical. Perpendicular to VB, if we draw VB horizontal, therefore perpendicular to VB will get vertical line. That means center of rotation becomes point I. Now to decide the direction of linear velocity of point C, as BC are the ends of rigid bodies and rod BC rotates about point I and VB is rightward, that means this IBC triangular plate rotates about I in which direction, that one will decide from VB. This omega must be clockwise. This is omega of bar BC. As omega of bar BC clockwise we are getting, therefore linear velocity of point C in the same sense of omega, if you consider, VC must be downward. This one is VC. As IB and IC directly are known in this problem, therefore directly we will find out linear velocity as well as angular velocities of the bars. First one, for bar AB, linear velocity of point B is equal to radius of rotation into omega. Radius of rotation is AB, therefore VB equal to AB into omega. We will find out VB. Then for BC, center of rotation is I, therefore VB is written as IB into omega BC. As you know, VB will find out omega BC, which is in clockwise direction. Then VC equal to IC into omega BC. What will get from this one? Directly VC, because omega BC is known. Therefore, simply you have to apply V equal to R omega, this equation for rod AB as well as for rod BC. First, we'll apply equation for rod AB. For bar AB, which performs pure rotational motion about point A. Therefore, VB is equal to AB is radius of rotation into omega of this bar AB. What is known? Omega AB is given, length AB is also given. Therefore, AB length is given in mm, 200 mm. I'll substitute in meters so that this is 0.2 into omega is given as 5. Therefore, linear velocity of point B equal to 0.2 into 5. That means we will get this one as 1 meter per second, and direction we will get rightward as we represented in figure. Next, for bar BC, as a point B is common, again I will write equation for VB. But for bar BC, center of rotation is I. Therefore, radius of rotation is what? IB into omega of bar BC. VB is 1. IB length given in problem, which is 150 mm. That means in meters it is 0.15 into omega BC. Therefore, omega BC is 1 upon 0.15. Therefore, this value, if you find out, if you calculate using calculator, comes out to be 6.67. This is in radians per second, and direction already you decided, it is what? Clockwise. Let me, this one is your answer, omega BC. Once you will get omega BC, next one, we will write equation for linear velocity of point C, which is IC into omega BC. IC length again given in problem, which is in mm, 450 millimeters. Therefore, in meters if you write, it is 0.45. Omega BC value you have calculated, it is 6.67 radians per second. Therefore, what VC will get here? VC equal to, if you calculate using calculator, comes out to be 3 meters per second. And what direction you are getting is what? Downward. What is asked in problem? Find omega of rod BC, which is 6.67 radians per second clockwise, and linear velocity of point C is 3 meter per second in vertically downward direction. Thank you.